Okay, here we have a problem from section 10.2. It's about blood pressure measurements in right arm and left arm. So the first step is you have to find the regressional equation y hat. So we need to find A and we need to find B. And eventually you also have to find R because you have to compare to the critical value. So let's turn on the diagnostic, go to second, catalog, and again scroll down. Every time you turn your computer off, and then when you have to find R again, you have to make sure that you turn the diagnostic back on, just to be on the safe side. So scroll down to diagnostic on, press enter and press done, and off you go. So first of all, your right arm values are your L1 values and your left arm values are your L2 values or your Y values. So we go to stat. Number 1 for edit, you have to enter them in a list. Now I already did the X values just to save some time. Now I enter the left arm values in L2. So 175, 170, 146, 145, and 144. So make sure you have the same amount of L1 values as you have L2. Okay, now we want the regression equation. So you go back to stat, move to calc. Now be careful here. The Pearson, this particular problem wants the regression equation input as a plus bx. So the x term comes second. If you scroll down, you see under number 4, you see a linear regression that is in the form of ax plus b. We don't want this. Scroll down further, and for number 8, so you have to use 8, you have it in the form of a plus bx. So that's the form we need. Press 8 or enter. Now you have to tell the calculator where are your values. So you have to press second and the digit 1. Right above the 1 you see L1. Then you need to press comma and then second the digit 2 for L2. That's what you should see on your screen. Press enter and then you get everything you need. So the A, the basically equivalent to the y-intercept is 68.8. We need to round to 1 decimal place. And B, which is the number in front of the x value, is 0.96. If we round this to 1 decimal place, you actually have to round it to 1. Okay, so that would be your regression equation as you can see it right here. Now we have to know, we know what R is. The linear correlation coefficient is 0.855. You can see it right here on your screen. We have to compare this value with the critical value to see if we can use the regression equation or if we have to do something else for finding the blood pressure in the left arm for 80. So click on the critical value table. Alpha is 0.05 and N in this case was 245 as well. So alpha 0.5, we get a critical value that is 0.878. So you have to compare this critical value with the actual R that was calculated in the calculator, and we see that our R 0.855 is smaller than 0.878. So when that is the case, we are not allowed to use the regression equation and just plug in 84x. Again, if the critical value is larger than the calculated value, or vice versa, if the calculated value you see in your calculator based on the data is smaller than the critical value, then we cannot use this regression line. If it was larger, then we can just plug it in. So what we have to do now to find the, let me close that out, to find the value for the left arm, we have to take the mean of all left arm values. So we have to find the mean. Now let me go back to stat. I have all my and edit for the list. As you can see, I have all my left arm values in L2. So now I'm just finding the mean for L2. I go back to stat, calculate, one variable statistics, and what I need is the mean for L2. So I press second and 2, enter, and we see the mean, X bar, is the mean of 156. So 156 goes right into would be for the systolic blood pressure in the left arm is 156. So again, if the linear correlation coefficient, the calculated one from our data, is smaller than the critical value based on the list, we have to find the mean of the values we're looking for. That's it.